So Delta Math doesn't have any videos for this next section, so I'm going to make one and post it for you. So we're finding the exact values of sine, cosine, tangent. That means that you can't just use your calculator. So before you could type in sine of 60 and get a decimal, but that's not what we're doing any longer. So here are the steps if you want to screenshot that or take a picture of that to evaluate. It says the 6 trig functions. We are going to do all 6 of them next week, but for this first week we're just going to do the main 3, sine, cosine, and tangent. So we're going to sketch the angle, find the reference angle, and then we're going to talk about drawing these right triangles so that we can label sides and evaluate the function just using SOHCAHTOA like we did before. So on the unit circle, which is something that we're going to talk about more in the next couple of weeks, and he's talked about a little bit in the videos that you have already watched. The unit circle is a circle that has a radius of 1, and it's set on the coordinate plane. So we have this circle, the radius of this circle is 1, and we're going to draw the angles like you have been this week, and then we're going to go and put triangles on it so that we can solve for sine, cosine, and theta. And these are the 2 triangles that we're going to use, the 2 special right triangles. So normally we would have had an entire lesson reviewing right triangles. You worked with them in geometry. We would have reviewed them. We're not going to do that this year, thanks to being at home. So you just need to have these somewhere written down. Take a picture of them, put them on a note card, have them handy. You are going to use them a lot in the upcoming couple of weeks. So this first one is a 30, 60, 90 triangle. That's because the angle measures are 30, 60, and 90. And this one is a 45, 45, 90 triangle. Again, because angles are 45, 45, and 90. So we're going to be given things like, let's do one just in the first quadrant right now. Cosine of 30 degrees. So if you look back up at those steps that I gave you, we're going to start with the XY axis, and we're going to graph 30 degrees like you did in the previous week. So 30 degrees would be about right here. Okay, there's 30. So we're going to make this into a right triangle. And remember I said during one of the classes last week that everything goes to the x-axis. So if we do reference angles, it goes to the x-axis. And when we draw these triangles, we draw that third side to the x-axis. So our other leg will always go up and down, and we'll talk about that a little more as we do the upcoming problems. So if we have this 30, 60, 90 triangle now, we have to label the 3 sides. The hypotenuse is always going to be 1. If we look up here, the side across from 30 degrees is 1/2. So across from 30 is 1/2. And the long leg is always radical 3/2. So then we go back to our SOHCAHTOA days, and cosine is adjacent over hypotenuse. So cosine of 30 degrees equals, here's our angle, 30 degrees. It's always going to be the one that's at the origin. The adjacent side is √3/2 divided by hypotenuse is 1. And then we're going to simplify that and get radical 3/2. So the cosine, the exact answer, cosine of 30 degrees is √3/2. You will not have any decimals. If you have decimals, you didn't do it right. Exact answers, these will have no decimals. Eventually next week we'll get to where we have to do a little more work simplifying these, but for this week tangent will have some, but sine and cosine won't really have any to simplify. So I'm just going to go and do several of these. Let's do, our next one is, I gotta turn it this way because I want to leave your right triangles up there. Sine of 210 degrees. So step 1 is to graph the angle. Remember this is 0, 90, 180, 270. So 210 would be right here. And we make it into a right triangle. That third side is always up and down, straight up and down. So the reference angle is the angle in here, down at the origin. How far is it from 180 to 210? That is a 30-degree angle. So we have another 30, 60, 90 triangle with 30 at the origin. We need to label the three sides. Hypotenuse is always 1. Across from the 30, the little angle is 1/2, because 1/2 is the shortest of the three. Of these three numbers, 1/2 is the smallest, so it's the shortest side. And then radical 3/2. But, and you've just worked with this a little bit, you watched his video with the sines. Since this is going to the left, remember we're on an XY coordinate plane. Here's 0, 0. Since I went to the left, this direction, this is a negative. I went left, root 3/2. Since this goes down, down is negative, this is negative 1/2. So you can either label them as you go, or you can just evaluate the number, and then you can go back and use his signs to figure out if it would be positive or negative. Sine, SOHCAHTOA, sine is opposite over hypotenuse. So from our 30 degrees right here, the opposite side is negative 1/2 over hypotenuse is 1, which just simplifies to negative 1/2. How about cosine of 225? So step 1 is to graph 225, sketch a graph of it. 225, remember here's 90, 180, 270. So 225 would be right in the middle. Draw the triangle. So third side's always up and down. Here's 225. What is the reference angle? How far is it from 180 to 225? So 225 minus 180 is 45 degrees. Okay, so this one's going to be a 45, 45, 90 triangle. The hypotenuse is 1. And the two legs are both root 2/2. So this is root 2/2. This leg is root 2/2. And just like in the last one, we have to pay attention to the signs. So this is negative, goes to the left. This one is down, so that is also negative. Cosine is adjacent over hypotenuse. So cosine of 225, the adjacent side is negative root 2/2, divided by hypotenuse is 1, which simplifies to radical 2/2. I want to do 2 more at least. I can do more and post them if you'd like, but I want to do one that is negative. Also would like to do a tangent. So I'm going to do a negative tangent. And then I want to do one that ends up on an axis. So let's do, say, sine of 270 degrees. Okay. When you watched the last delta video, he talked about, let's go back to this one for a second. He talked about the x and y coordinates, right? So he had an x and y coordinate right here, and he told you that cosine is the x coordinate and sine is the y coordinate. So cosine is the x coordinate and sine is the y coordinate, which is important for an angle like this because we're not going to be able to draw a triangle. 270 degrees is straight down here. So 270 would be right there. I don't have sides to make a triangle out of. I can't draw a triangle right there, so I don't have an opposite, adjacent, and a hypotenuse. Remember that this unit circle has a radius of 1. So if I have a point down here, that point is 0, -1. Okay? If I had a point over here and the radius is 1, that would be 1, 0. A point straight up, that would be 0, 1. Point over here to the left on that circle that has a radius of 1, that would be -1, 0. So sine of 270, here's 270 down here, that ordered pair is 0, -1. Sine is the y coordinate. The y coordinate down there is -1. So sine of 270 is -1. The last one that I'm going to do for this video, we need to do a tangent and we need to do a negative. So let's do tangent. I should do -225. Okay. So again, we're going to graph it. Here's 0, negative, so we're going to go in the opposite direction. So now if we go this far, that's -90. If we go around to here, that's -180. All the way up would be -270. So 225 is going to be in here somewhere. -225. Draw our triangle. So that third side is always going to go up and down, vertical side. The hypotenuse is always 1. And we need our reference angle. So how far is it from 180 to 225? I know it's going in an opposite direction, but how far from -180 to -225 is 45 degrees. Remember, reference angles are always positive because we're talking about a distance, and they are, or length, and they are always acute, always less than 90. So from 180 to 225 is 45 degrees. That means we're using the 45, 45, 90 triangle. The two legs are both square root of 2/2. This side goes to the left. So this is negative radical 2/2. This side is going up, so that's positive root 2/2. Tangent is TOA, opposite over adjacent. So from our angle down here, the opposite side is root 2/2. I'm going to go put it down here. So tangent of -225. Opposite side is root 2/2 over TOA. Adjacent side is negative root 2/2. If we simplify that, something divided by itself is 1. So root 2/2 divided by root 2/2 is 1. And because one of them is negative, it's -1.